So in section 2, what we want to look at is matrices and how they work and what they do and all the different ways that you can utilize them. And so usually when you're talking about a matrix, you're going to have rows and columns. So the rows are going to be these guys right here. Rows go this way. And then columns are going to be these guys right here. They go up and down. Okay? And you usually call this matrix would be m rows by n columns. Okay? So rows here, columns here. Okay, so each element uses a subscript to describe its by row then columns. So if you have some matrix, if m equals n, the rows and columns are the same, you have a square matrix, and then the order of the matrix is the rows by the columns. So equal matrices have the same order, and their corresponding elements are equal. So in order for two matrices to be the same, they've got to have the same number of rows and columns, and then each thing on the inside's got to be identical. So if we're just going to determine the order of these guys, you go rows by columns, so this is 3 by 3. You go rows by columns, so this is 4 by 2, and then rows and columns, so this is 2 by 3. So rows and columns, that's all there is to it. And you've got to understand this part, though, to set you up for what's coming next. And if we're going to use these matrices, then what we're going to do is, one of the things that we can do is add them up. So in matrix A, we're given the mean SAT verbal scores for 6 New England states over a 4-year time period. And in matrix B, the mean SAT scores for the same time period. And we want to express the mean combined scores for these New England states. And so when you add a matrix, then what you're going to do is you're going to take the matrix in that position 1, 1, first row, first column, and add it to the number that's in the second matrix in the first row, first column. So when you're looking at your new matrix, if you look at A plus B, then that's going to be equal to 509 plus 510. Well, and you do that then for the first row, second column, or second row, first column. So 506 plus 500. And you do it for the third row, first column. 511 plus 515. And you do it for the third row, first column, 520 and 516. And you do it for the next one. And then you do it for that last guy. And you do this for every row and column and all the corresponding parts. And I'll just fill all the rest of those in purple. So there's my first row, first column. So first row, second column would be 509. And then 503 plus 502. And so we're just going to fill all these in. So then when you add all these guys up, you're going to end up with a matrix, A plus B, which is going to be equal to the sums of these things. So this would be 1019, 1006, 1026, 1036, 1,000, and then 1017. And you're going to fill in the rest of your matrix just by adding those guys up until you've got them all put together. Another way that we can use a matrix is by looking at comparison of things. So let's say we're a consumer advocacy group and we've looked at some retail prices for brand name products and generic products at 3 different stores. And we've got a 7.25% tax rate. So construct a matrix showing the comparative prices with the sales tax included. Well, what that tax rate means is we're going to take that 7.25%, we're going to turn it into a decimal as a tax. So it's going to be 1.0725, and we're going to multiply it with this matrix here. And this is a scalar, and when you multiply by a scalar, then you're going to multiply each individual piece inside the matrix by that scalar. And when you do that, you end up with your new prices at store A, B, and C for both generic and the brand name. So the brand name first at store A, B, and C. So $4.26, $4.26, $4.05, $4.02, and then the generic is going to be $3.90. And again, this is with your tax figured in here, so $3.96 and $3.93. So there's your matrix, and you can use that in a lot of different ways if you're comparing prices and exactly how things are going to work and get marked up. Now we can look at matrix multiplication. So, if we look at different floral arrangements for Mother's Day, roses, carnations, and lilies, and the different places, the two warehouses that we can get it from, what we can do is we can construct a matrix that shows how much it costs to make each type of flower arrangement, and then what the price would be to be able to determine, which warehouse is going to be the best place to buy the flowers from. So basically, when you multiply, we're going to take and look at the order of the matrix. So this is a 3 by 3 and this is a 3 by 2. You can only multiply a matrix if these two numbers are the same. If they're not the same, you cannot multiply the matrices. The order of the finished matrix are these two numbers right here. So when we work out A times B, we should get a 3 by 2 matrix. And when you multiply a matrix, you're going to take a column, first column, and multiply it and add it with the first row. So it's going to look a little bit different, but here's how it's going to go. It's going to take the first column times the first row. So first column, first row is 5 times first column, first row, 1.5, plus first column, second row, 8 times first row, second column is 8, and then the second row, first column, 0.95, and then first row, third column is 7, and then third row, first column, 1.3. And we're just going to follow this pattern the rest of the way through the problem. So this is going to be 1.3. And then you go to the second row, first column. So now we're going to take this guy right here off. Okay, he's gone, and now we're going to look at the second row, first column. And we're going to multiply in the same order. So 6 times 0.15, 1.5, plus 6 times 0.95, plus 7 times 1.3. And then we're going to look at the third row, first column. And again, it's the same pattern. So it's going to be 4 times 1.5 plus 3 times 0.95 plus 3 times 1.3. That's the first row, first column. And then we go first row, second column, and it's the same exact thing, but now instead of looking at this first column, Instead of looking at this first column, we're now going to look at the second column and take all the exact same steps right through here. So 5 times 1.35 plus 8 times 1 plus 7 times 1.35. And we're going to fill this guy in the exact same way. So 6 times 1.35, second row now, second column. 6 times 1 and 7 times 1, or 1.35. And then 4 times 1.35 and 3 times 1 and 3 times 1.35. And when you multiply and add all these guys up, you're going to end up with your final matrix, which is going to be 1840, 2160, and 2105 for your first column, and then 1815, 1815, 2085, and 2050. So when you multiply all those numbers and add them all up, this is what it looks like. Well, your columns stay the same. This is warehouse 1, this is warehouse 2, but now your rows have changed a little bit. Now this is arrangement 1, this is arrangement 2, and this down here is arrangement 3. So we can look at these guys and figure out, okay, which one of these has the best prices for us to do our shopping.